Okay, so today we're looking at the second half of rules that would be considered probably the more difficult half of rules. And we're going to look at applying them. Specifically, we're going to look at negative powers. In front of me here, I have the 9 rules. You don't need to know these 9 rules off by heart. They're given to you on the day of the exam, but you do need to be able to recognize what rules will help you. And I would definitely say with indices, it really is a process of trial and error. And by that I mean try something. If you don't get the desired outcome, go back to the drawing board, try something again, and never get rid of the work you've done, because the examiner will take all that into account. Okay, which brings us to example 1. Using only the laws of indices, evaluate the following question. 27 divided by 64, all multiplied by minus 2 over 3. And instead, we can't use our calculator here. We are only allowed to use the laws you see on the left. So it's really important whenever you're doing these that you have the laws open in front of you. Okay, so the first thing I can see here is I have a minus power. And so for me, that has to be something that I address straight away. The only rule here that has a minus power is this one here, which essentially says that if I have any number to the power of a minus number, we must put 1 over that number to the power of that number. So kind of sounds a little bit tricky, but we will fill it in as so on. In this question here, my 27 over 64 is my A. It is the number. Okay, then we have the minus, and my M in this case is 2 over 3. So this will be my M. And I'm going to apply rule 5. So if I apply rule 5, my new sum becomes 1 over 27 divided by 64, all to the power of 2/3. Okay, I've gotten rid of my negative power. I am faced with 1 divided by and all of this work underneath. I'm going to, for the time being, ignore the top half and focus solely on the bottom half of that equation, of that expression. So I can see here I have 27 over 64 all to the power of a fraction. So is there, first of all, something that will be similar to that? And you can see here we have this to the power of a fraction and this to a power of a fraction, but we don't necessarily have something that is divided by something to the power of a fraction until we get to law 9. So I'm now going to apply law 9 here, and you can see that the 27 is my A, and the 64 is my B, and the 2/3 is my M. And I'm going to apply now law 9. If I apply law 9, I'm now going to have 1 over, and it's going to be 27 to the power of 2 over 3, all divided by 64 to the power of 2 over 3. Okay, I have now got a situation whereas I'm still focusing, as I said, I'm still focusing on the bottom half. I'm not too worried yet about the top. I'm going to focus on where the indices is. And I have 27 to the power of 2/3 and 64 to the power of 2/3. So I'm going to look now and see if there's a rule here that has a number to the power of a fraction. And as I get down, I can see that rule 6 has a number to the power of a fraction, but the fraction must have a 1 on it, so that's not going to help me. But rule 7 has a number to any fraction. So I'm now going to apply rule 7, make this a little bit smaller, and apply that. Okay, so rule 7 now means I have 1 over, that hasn't changed. Now, 27 to the power of 2/3. Now, if I was just to focus on that and use rule 7 for that, that would mean that it became my q became my square root or my root. So in this case, it's going to be a cubic root of 27, and that's all to be squared. So I'm now going to rewrite that as cubic root 27 all to be squared, all over cubic root 64 all to be squared. And at this point here, I can use my knowledge on squares and cubes to figure out this sum. So again, I'm going to have 1 all over. The cubic root of 27, if you type that into your calculator, you should get 3. So that'll be 3, all to be squared, all over. The cubic root of 64 will be 4, because 4 times 4 is 16, times 4. So that will give me 4 all to be squared. And I can finish that off a little bit more. So that now means it's 1. All divided by 3 squared is 9. So 9. All divided by 16. And so another way of writing this that you have been looking at for many, many years is this is 1 divided by 9 over 16. It's another way of writing exactly what I've written here. And basically what you're doing here now is you are asked to divide one thing by another. How we would approach this in first year is we would say we'll write them both as fractions. So it'll be 1 over 1 divided by 9 over 16. And as we know ourselves, how do you divide a fraction? You change the symbol to a multiply and you flip the second one upside down. So now it becomes 1 divided by 1 multiplied by 16 over 9, and we can just do our simple multiplication. 1 times 16 is 16, and 1 times 9 is 9, and that is the answer for 27 over 64, all to the power of minus 2 over 3. We apply the laws, and we got 16 over 9. We can indeed break it down a little bit more if we wanted, and write that's equal to 1 7/9. Okay, so ensure that that example is clearly written down in your copies and that you understand every step. Okay, the next question we're looking at is using the laws of indices, show that 0.75 all to the power of n is equal to 3 to the power of 9, all to the power of 9 is equal to 3 to the power of 9 divided by 4 to the power of 9. So we have now got 0.75 to the power of 9, and we want to make it equal this. Well, another way of writing 0.75 is writing 3/4, and that's all to the power of 9. Now, if that was the case, what law could I apply here to help me get that to be 3 to the power of 9 divided by 4 to the power of 9? And it is the last law, law 9, which means if I have a fraction to the power of something, another way of writing that is saying that that's 3 to the power of 9 all over 4 to the power of 9. So another way in which that question can be phrased, asking us to solve using our laws of indices. Learning check tonight is activity 5, part 4. You're going to do for me this first question here and this second question here. I think the numbers have just been taken off, but these 2 full questions for me for tomorrow.